This is Kishore and welcome to Kishorelytics. If you are someone who loves to explore the data and learn SQL and build data projects and dive deep into world of analytics, you are in the right place. On this channel, I break down the complex topics like data warehousing and SQL queries and dashboards in a just simple and practical way. Whether you are just starting a journey and leveling your skills, I just cover. So hit the subscribe button and join me in this exciting journey and turning into data into the insights. One of the video at a time. This is Kishore and you are watching the Kishorelytics. Let's get started. In this video, I am coming with 5 SQL queries that are not just theoretical. These are the real-time examples of SQL queries in the real-time interviews. We will cover things like joins, window functions and subqueries and aggregation and more. And all data breakdown in break step by step. So grab your notebook, stay focused and let's level up your SQL game together. So in the first questions there are 5 questions in this video. The first question is like find the first date by each users reach their third purchase. The table name is purchases and we are giving the challenges as for each users who has made at least 3 purchases. So return user ID and purchase time. So for this query, I'm creating the tables like create table purchases as in this table. So in this table, I am keeping the user ID and purchase time as the records. I have already created the table. So just I am executing the query. Okay, so working fine. I think so. I have already inserted the table. So let's jump into the query. Things like first, I am solving it by keeping the CTEs. So with I am naming a city as ranking purchases, right? As sorry. Okay. First, we are selecting the user ID and the purchase time from the table. Purchase time from the table, and first in the table in the city we are creating the row number, that's the window functions. So in the window functions we are creating the row number functions and it's overing it by I mean it's grouped by partition by the user ID coming with, and I want it ordered by the purchase time, right? Sorry, purchase spelling is wrong, right? Purchase time, and I'm keeping a aliases as RN, so it's row number and fine. And it's which table it's coming from? It's coming from the purchases tables, right? And I'm just closing the bracket and entering into the main query. I'm just selecting the user ID. I'm just selecting the user ID. So with that, I'm selecting the user ID, and I want the purchase time as well. Yes. So I'm keeping the purchase time as well, and it's coming from the CTE, right? So I'm keeping the CTE as ranking purchases, and the condition parts is where Rn is equal to 3 because the question itself says for each users who had made 3 purchases in the same day. So it's coming with 3 purchases, right? So this is the query. First query is simple as well. I try to executing this. Why the output is not coming, right? Wait, I'll check it. User ID, purchase time, it's coming from the ranking purchases. Wait a minute, I will cut as well in the table, so it's so that the answer was empty. I just correct it in the table, so the answer is yes, right? User ID and third purchase date, right? It's coming from the 1 and 2 4 6 7 tables. It's easy, right? First complex queries are completed. In the previous session we have discussed about which the customers have purchased the 3 items in the same day. And in this session, we are discussing about the advanced SQL, the find the employees with the largest salary gap between the consecutive years. The tables are employee salaries, and the task given for us is the for each employee, they calculate the difference between their salaries and from the consecutive years and return the previous year salary, return the largest salary, right? Largest salary for each employee. You should also return the 2 years between the gap between them. Okay. The expected output column is that the employee ID and the salary gap. That is the largest difference between the consecutive years and the year one salary, the previous year salary, the earlier salary. That means and the year two salary, the later area salary. And the concepts that are using it is the window functions like lag lead. The lag functions are used to look into the previous row in that table, and the lead functions are used to get the next element in the table. And we are using the self joins in the table. So for consecutive year congregation, and the aggregation is used to find the minimum gap between them. So the I have already written the query. So I'm just explaining the query. First, we are create. First, we want to create the table. So we are creating a table. Yes, the command successfully. We are creating the tables like creating the table name is keeping the table name as employee salaries, and the argument are passing into the tables are the employee ID and the salary year. And the table was successfully created, and we are inserting the some records, sample records into the table. So just already written. So I'm just querying it. Says 12 rows are affected, and we'll be trying into the deep dive into the query section. Okay. First, we are using the CTE as with CTE as the salary differences. We are using the CTE name as salary differences, and we are getting to the CTE. We are selecting the employee ID and the salary year and the salary. First, we want to use the lag functions. So the lag functions are we are discussing about the lag functions. The lag functions are used to get the previous record in the row. So we are using the lag of salary. So will get the previous salary. So we are group by employee ID. So in particular employee ID, we are want to see the previous year ID. So partition by employee ID, and we are ordering it by salary, and default is the ascending. So I'm keeping a aliases name as previous year salary, and we want to see the salary year. So we are using the same lag functions. So lag of salary year, and we are partitioning by employee ID, and same we are ordering by salary year, and keeping a aliases name as previous year, and it's coming from the employee salaries tables. So this is the CDE, and when I'm trying to execute this state query, see it's created that employee ID, the salary year, the salary, previous year salary, and the previous year. Okay, say let's analyze this table, right? First, in the employee ID one, the salary year is 2022, and the salary is 60,000, and the previous year salary is 55,000, and the previous year in the 2022 is the previous year is 2021. Okay, and in the employee ID 2, the salary year now the current year is 2020, and the salary for the employee 2 is the 45,000, and the previous salary the employee are new joinee, so no, there is no previous salary and the previous year. So that's it for the table. So let's get into the consecutive, and the main target in the section is to find the consecutive gap between the salary. Okay, so we are selecting the employee ID, the consecutive gap as salary gap for which coming from the absolute functions. From the we are finding the difference between the salary and minus the previous year salary, and we want there is salary with no negative numbers, so we are keeping it as the absolute function. Absolute function is used to make the minus values to plus value, so we are using the absolute functions as absolute of salary minus previous year salary as salary gap. We are keeping aliases name as previous year gap, and previous year as year one, and salary year as the current year salary. That means keeping a salary year as year two, and it's coming from the CTE, the salary differences. So where the previous salary we want the not null, we omit the null values. So there is no previous salary. Why we want to see the consecutive gap? So we are leaving the null values, and we are ordering by employee ID and salary gap, and we are ordering it by descending order. Okay, when I try to execute this query, see the employee ID one, the salary gap between them is 5,000, and year one is the differences between the previous year salary and the current year salary. The we discussed about the employee one in the previous uh, section. Discussing about the employee one as getting the 50,000 as the previous year salary and 55,000 as the current year salary. The difference between them as the 5,000. So we are keeping the and the year as previous year as 2,000 and the current year as 2021. So I'm just entering a query. Are you able to understand? I am keeping as understanding purpose. So that's it for this question. In the previous session questions was understood, I think, right? And in the third session, we are analyzing the advanced SQL queries like recursive CTEs, right? In this question, what's the question, right? Let's read the question. First, find the longest chain of the each employee. First, we want to find the longest chain of the each employee. So the table given is that the employees and the task for given for us, right? For each employee, find the longest chain of the members they have, starting from the employee to the highest level manager. We want to find the chain of the managers. First, we are joining the company as an employee and we are promoted as a manager. The gap, we want to find the chain between the employees, the longest chain of the manager from employee to manager. So first we want to return the employees employee name and number of the managers in the longest chain they have. The number of the managers they have the longest chain. So the expected output column has the employee name and the manager channel length. And in this session, where the concepts used as the recursivity to transfer the hierarchical data. So we want to find the manager chain, right? So first we want to find the manager ID. So with the manager ID, it's going from the hierarchical. It's like a tree-based structure. With the root node, it has a tree node. It has a child node, right? With the root node, there are two child nodes are connected with the root node. So we want to find using the recursive CTE as the CTE and the aggregation to use the length of the chain, and window function is use the max window function. So first we want to create the tables. I have just already creating the query. I'm just executing the query. The commands are successfully completed successfully. We are creating just creating the table employees, and in the employees table, in the employees table we are giving the arguments as employee ID and the employee name and the manager ID. And the employee ID, the data type is the integer, and the employee name, the data type is the varchar, and the manager ID, the data type is the integer. And let's add some, right, let's add some few records into the table. Yes, I have inserted the 7 records. I have just already written the query, so I just explain the query. So first, it is a recursivity. We want to explicitly mention that recursive. So with recursive, it is mean by a recursivity. It's with recursive. The city name as the manager chain as, and getting into the CTE, we are selecting the employee ID and the employee name and the manager ID, and one as the chain length. So why one as the chain length? So first we want to give the starting point, right? So with the starting point, it goes to the child node and another child node and baby node and something else. So we are giving the one as the chain length. It's coming from the employees table, and we want to ignore the higher questions. So where manager ID is not null. So we are union all. I tell it later why we are using a union all, and we are selecting the in the second recursive case. Yeah, so in the recursive case, we are selecting the employee ID and the employee name and the manager ID and the chain length between them. MC dot chain length. I will tell this later, and it's coming from the employees table and keeping Alexa's name as E, and we are joining the manager chain. Yes, the CTE. So it's a CTE, and we are joining the manager chain CTE and keeping the Alexa's name as MC, and which condition we are joining as employee ID is equal to the manager ID. So we are telling us the employee ID is e dot employee ID is equal to mc dot manager ID. So the employee ID is coming from the employee table and the employee name is coming from the employee name employee table, and the manager ID is coming from the employee table. The chain length is coming from the manager chain CTE. So we want to add it from we are giving the starting point and we want to add from one by one. So we are doing this the channel length chain length as one. So with this I have explained the recursivity why the union all is used. We want to join it. So join is used to combine the tables. Similar to that, the join is the unions comes with, but the unions as a condition. With the union as a condition, so that right. I have joined the tables, but it wants as a similar data type. So we are using a join. So in the recursivity, we want to completely conformly use the union all function. So first the recursive part base case, and the second is a recursive case, so that the recursivity will happen. So let's enter into the main query, and we are selecting the employee name and the max of the chain length. So we want to find the max chain length, right? So we are keeping the max of chain length as we are keeping the alias name as manager chain length, and it's coming from the manager chain CTE, and we are grouping group by employee name, and we are ordering by manager chain length descending order. So yes, I have explained well. So the explanation of this session is that the recursivity is used to build a chain of the managers for each employee. So we are keeping the one of the chain length and we are adding by one. So I have explained before. And the base case, first the base case is I have the direct manager ID is not null. So we are omitting the manager. So the manager itself is always having the higher position. We omitted the manager. So we are taking the employees only. So we are using the manager is not null. So in the third and the recursive case joins employee the channel length by one. So I'm telling right, we are keeping the one as a start length and we are incremented by one. So mc dot chain length plus one here, right? In this case we are using, I am telling explaining in this case. So we are using the chain length by one and we are implementing the max of chain length. So I want to find the max of the chain length and the result is stored in the longest manager chain length. Yes, right. And the key concepts covered in this sessions, right? Recursive queries. Using with the recursive queries, you can able to handle the hierarchical relationship like manager-employee chains. These are the examples for the recursive query. The main interview questions asked with the recursive queries are the employee-manager chain. There are more examples are coming with the recursivity. The main examples is the manager-employee chain, and the aggregation is used here is the manager, sorry, right? And the aggregation is used with the max function, and we are self joining the table as self joining, right? Yes, we are self joining the same table. We are separating the e dot employee id into manager dot id. So we are self joining. In this session we are learn recursivities and max city aggregation functions and joins. So I think the output of the recursivity is that the employee name and the manager chain length. The chain length of the John Doe is the 3, and the Ali Smith is the 2, and the Bob Johnson is 2, and the Charlie Brown is 1, and the David Wilson is 1, and the Eva Davis is 1, and the Frank Milter is 1. That's it for the session. I understood. I think you are able to understand the previous sessions, right? In the previous session we are discussed about the find the longest chain of the members for each employees, and in this session we are discussing about the challenge given for us is that the get the most frequent job title per department. The ID is giving as employees, and the task for given as for each department return the job title for each department. It's right, note the point. For each department they are asking the for each department itself we want to know about the group by. So return the job title that appears most frequently, right? For example, the most common role in the other department. If there is tie, return all the tie titles. Okay, fine. And the expected output columns they are asking as a department and the job title and the count of the title. And the concepts in this section we are using as the group by and the rank or the disk rank functions with partition by and the CTEs or the subqueries. So first we are creating the tables, right? First we want to create the employees tables. We have add the elements because I have already the tables, right? Employees, so I have few more SS in this table, so that only I am adding the SS execute. When I try to execute, the table has been created, and the table has been created as the employees, and the records in the field columns as the employee ID, and the data type for the employee ID is the integer, and the employee name and the data type for the employee name as a varchar, and giving the size as the 100, and the department, and the department in the department the data type is the varchar, and we are giving the varchar of 100 size as the characters. And first and the final but last and but not least, and we are giving the job title, right? Job title, and in this we are using the data type as varchar, and we are giving keeping the size as 100. Okay. And first I want to include I forgot how many SS I have been added. So yes, one, there are 5 SS, right? I want to add the four remaining 4 SS, 1 2 3 4, right? In the employees we are adding the employee ID, insert into the tables. Just I am just inserting the dummy values in the table for exam, showing the output as the answers, and I am inserting at the 10 rows, and there are 10 rows are inserted affected in the tables. Okay, let's get into the query. Let's quickly get into the query, and it's an interesting query. And fine. In with I'm using a CDE. I have discussed in the previous in this session. We are using a CDE as the title counts, with the CDE name as the title counts, and getting into the CDE we are selecting the department and the job title. The job title has been given in the table itself. We are selecting the department job title, and we are count for as the count of the title. We are using the aggregation functions as count. It counts all the values in the function. So we are using the count function as keeping the aliases name as the count of title, and which table is coming from the, it's coming from the employee. I want to add the 4 SS, right? And the just give the tab, and it would enter the table name, and which employee is coming from, it's coming from the employees, and we are group bying it by department and job title. So in the college where there are various departments, like there are students in the table, so they are the student in the college, they are studying the various department, like they are studying the 5 students are studying the ECE, and 5 students they are studying in the ECSE. So we are group bying it by single ECE, CSE, IT, AADS, and just like we are group bying it by department. And there are various job roles in the IT company, like software developer, software developer. We are group bying by software developer, data engineer, cloud architect, and there are many roles in the IT company. Let's discuss about it later. And the second city we are using it as first in this city. I am just trying to execute this. Yes, we are grouping by department, job title, and count of the title. Okay, okay. In the records there is a marketing department, and the job title is the content writer, and there are 2 marketing departments in the table, and 2 content writers in the table. Okay, right? Engineering, DevOps engineer 1, and the HR manager 1, and the HR recruiter 2, and there is a marketing SEO specialist, right? And 1, and engineering software engineer as 3. Okay, fine. And quickly I'm getting into the second CTE. In the second CTE I'm keeping their name as the ranked titles, and as I'm just entering into the query, entering into the CTE. I'm just selecting the select star. It's coming. I have selected all tables, all the records in the tables. So I am using the star. So in this CTE, I am using the rank window functions. It gives the rank for all the records in the table. If it's repeated, it gives the new rank to other same employee ID. If you are using the dense rank, it gives the same. If we add the same employee ID as the same 2 and 2, it gives us a employee ID as 1 and 1. Okay, I'm trying to explain this quickly and fastly and clearly. And using the rank function, and I'm using the rank function, and we are using the over it by part. We are grouping it by department, and we are ordering by count of title, and it's coming from the descending order. The default is the ascending order. I have discussed about many times in the videos, and keeping the analysis name as rank or NK, and it's coming from the above CTEs, right? It's coming from the above CTE, and when I try to no, the CTEs is the temporary tables that is stored in the database. So in this session we are not able to querying this, and let's enter into the main query. And the main query, we are selecting the department and the job title and the count of title, and from it's coming from the ranked titles, and where we want to select the. So see, the question itself asking that for each department return the job title that appears most frequently. The most frequently is coming from the first, right? We are descending group by it and descending the table. So it's in the top order. So we are asking it as one, and we are ordering by department. So I'm just try to execute this query, just starting the query and executing the query. Yes, in the software engineer, and the count of the title is 3, and Kanchar, the recruiter, the most job title used, and it is 2, and the marketing, the rest, most job title is content writer, and it is 2, right? Um, let's dive into the explanation part. This query identify the most frequently yelled jobs title in the each department. So there are more departments in the colleges. We are discussing the session, and more job roles in the each department. So discussing the previous in this session, and in the first step, we are using the CTs as title counts, and we are grouping by employee table and grouping by department and job title, and counting how many employees hold each title within the each department, right? And in the second, we are using the second city as the rank titles, and apply the rank window function to rank the job titles by frequencies and count of the titles within the each department. We are using the partition by, and we are partitioning by a department ID, and the highest rank title is in the rank 1. The outer query, yes, that means the main query, right? Right, the main query, the filters only the rows where r and k is equal to 1, because the most frequented answer is in the rank in first rank. So we are taking the rank functions, and in this session we are using the key concepts as CTEs. The CTEs are used to separate the logic cleaning for counting and ranking. So, and second, we are using the group by uncount to count how many values hold each top title within the each department. And we are using the middle functions as the rank function is used to partition by the partition to find the rank job separately for within the each department. So, and in the partition by, we are resetting the partition by where each department group, right? In the ECE department there are various job details, right? We are group by partition by each department group, and we are filtering the rank results as R and K is equal to 1. The most rank is appears in the rank 1. So, and we are using the finally sorted by department ID. That's it for the session. I explained by well, and I'm able to understand. Are you able to understand? I think I are able to understand, right? And I try to executing the query and again. Yes, the same answer will be coming. The engineering, software engineer 2. That's it for the session. Where in the previous session we are discussing about the get the most frequent job title question, right? In this session we are discussing about the monthly active users, right? MAU with rolling 3 months count. The tables are using given us as a logins, and the task for given us is that for each month present in the data, find the number of unique users who logged in during the month or any two preceding months, right? If a 3-month rolling window of activity, the expected output column as month active users, month as the string, and the active users the number of the distinct users act in the last 3-month window. You want to find the 3-month rolling back users, right? It's very important questions. And in the explanation process, first we want to build the logic, right? First we want to, in the step 1 we are creating a city as login month, and we want to extract the year. The given tables contains year and month from each login date and converting into the month format. We are just want the month, right? We don't want the year and day. That's it. We omit it, right? We are just converting the month. We are and to extract the month format. And in the second step we are using the distinct pass city and keeping the name as distinct pass city, and we are creating the self join into it to assert the each login month and as the May month with the users and who logged in the during the month or two prior months. So this is the rolling three back window. You want to first if we are in the May month, and we want to if we want to in the April month, or it's in the March, or it's in the February. Even this is the rolling three back month window. And the final select groups, and the final query explains that we select the groups the data by base month and the count distinct user ID CTEs to get the number of the active users who logged in the 3 months rolling window. And in this session, we are using the key concepts as the date transformation. We are using the day use format function to format the date and extract the date from the year to month. And we are using the self join. It is used to rolling time across the months, and we are using the date between plus date add dynamically creates a rolling window of 3 months using the data arithmetic, right? Right, and we are distinct plus count. In the distinct plus count, we want the unique IDs, and we want to count the each ensures that only counted per 3 months only. So we are ordering and order by it ensures the order by chronological order, sorted by month, and anything itself it's ascending or the descending we will explain in the core session. So let's dive into the quickly into the query sessions. First, we want to create the tables. Right, in the tables, I'm creating the create tables logins as a table name, and in the tables, I am giving the field arguments as a user ID, and in the user ID, the data type is used as the integer, and the login date in the login date, I am keeping data type as the date functions. Right, date data type. I'm trying to execute in this, and the table has been successfully created, and I'm just inserting the dummy records. Sorry, I'm just inserting the dummy records in this table. Yes, there I am inserting the 11 tables. So let's dive into the quickly into the advanced query sessions, right? And as discussed in the previous session, in this session before, a little bit before, we have discussed the step-by-step process. So we are implementing the step-by-step process, and with first we want to create the login months as the giving as the name of the CTE. First we are giving this name of the CTE as the login months, and quickly enter in the CTE, and in the selected CTE selecting the user ID, and what we in this first step we want to accept the month format. So in the month format we want in the date function we want only the month. So we are extracting the month. So we are using the foreign function as the login date at the year y and the login month, and it's coming from the logins. And I trying to execute this query. Yes, login month format of the login month. We are in the login month date. We are using the 2025 year and date. Okay, see, they are giving the year, month, and date. Okay, we want only the year and month. So we are using the form logins function. And let's get into the second CTE. In the second CTE, we are keeping the name as a distinct pass, and we are selecting the distinct month. So first we want to find the login month as given in the login month as in the CTE. It's coming from the CTE, and in the login month as the base month. First we want to find the current month. Okay, it's coming from the login month, and we want to find the user ID. So in which user ID it's coming from? If it is from the user ID 1, it's in the month login month as a April. So in the second user ID, in it is the name. It's in the second column. It is in the first user ID, and it is in the May month. So we are finding the user ID, and it's coming. We are self joining it, right? Login month as LM1, and we are using self join as login month and LM2, and based on the conditions, right? It's in the first month, it's in the current month, or it's in the previous month, or to previous month, and we are proceeding login month, right? In the login month we are using the current month, and it's between the 3 months. Between means we are 1 2 3, we are using a 2 as a between. In this SQL we are using a 2 as a between. So 1 to 3, it's between the 1 2 3. It checks from the check CTE, and we are adding the date add. We want the first, let's execute it step by step. So in the login month we are checking the previous month as the date, and we are checking the previous 2 months, or it's in the current month. Okay, that's it for the CTE. and in the main city we are selecting the basement as the month, and we want to count the distinct user id. The word distinct means it gives the unique user id from that table, so we are using the distinct user id, and it's coming from the distinct pass, and distinct pass is the in the second city, and we are grouping in the basement, and it's coming from the we are ordering by basement. When I'm trying to execute this query, so see, the users right, the active users right 2, employee ID 2, sorry, the user ID 2, and they are logged as 1 1st January 2024, and the table user ID 3, they are logged as 2 2024, and it means is the last login date. They are logged the pre-rollback actions, and the user ID 4 and the user ID 5, sorry, the user id 4 are creating the, that means they are logged as 6 months, so that only it's coming the 2 4 2 as 2 times. So in the fifth user id they are 2024 as 2025. I think I am able to cover all the advanced sessions, advanced concepts in this session. So the key concepts used as the data transformation, self join, between, distinct, order by, and in the previous key concepts are a rank function, and in the third session the key concepts used as the recursivity. In the fourth session we are using the lag function and lead functions. Many functions I have explained in this story, and that's it for the session, and that's it for the video. And if you find this video helpful, please make sure to share with your friends and like it, subscribe, and if you give the one subscribe to me, it gives a motivation to create more useful videos for you. Getting into the end of the video. If you find the video useful, like it, subscribe it, and share it with your friends. Thank you. See you later.